Hello everyone. Welcome to Consumer Times. Today, we're diving into a fascinating topic that plays a crucial role in modern industries: ultrasound technology. While many associate ultrasound with medical imaging, its applications extend far beyond hospitals and into industries such as manufacturing, metrology, and non-destructive testing (NDT). Before we further dive, please comment, like, share, and do not forget to subscribe our channel to motivate us. So, let's explore how ultrasound is shaping industrial standards and quality control processes. Understanding ultrasound technology. Ultrasound refers to sound waves with frequencies higher than the audible range of human hearing, typically above 20 kHz. These waves travel through various materials, reflecting, refracting, and attenuating based on the properties of the medium. This characteristic makes ultrasound an essential tool for inspecting materials without causing damage. In industrial applications, ultrasonic waves help us detect flaws, measure thickness, and even characterize materials at a microscopic level. But how does this work in real-world scenarios? Let's break it down. Ultrasound in metrology and measurements. Metrology is the science of measurement, and accurate measurements are the backbone of any industry. Ultrasound plays a pivotal role in metrology, especially when it comes to measuring dimensions, material properties, and structural integrity. One of the most common uses of ultrasound in metrology is thickness measurement. Industries like aerospace, automotive, and construction rely on ultrasonic gauges to ensure components meet precise specifications. These devices work by sending an ultrasonic pulse through a material and measuring the time it takes for the echo to return, allowing us to determine the thickness with high accuracy. But that's not all. Ultrasonic velocity measurements help us analyze the material's elastic properties, such as density and stiffness. This is particularly useful in quality assurance processes where material homogeneity is critical. Ultrasound in industrial standards and quality control. Standards ensure consistency, reliability, and safety in industrial applications. Organizations like ISO, ASTM, and ASME establish guidelines that industries must follow to maintain quality and safety. Ultrasound-based testing methods are widely incorporated into these standards. For instance, ISO 16809 specifies the ultrasonic thickness measurement requirements, while ASTM A114 outlines ultrasonic pulse echo testing techniques for detecting flaws in materials. One example is the quality control of welded joints in pipelines. Standards mandate ultrasonic inspections to detect internal defects such as porosity, cracks, and incomplete fusion. This non-invasive method ensures the structural integrity of materials before they are put to use. Ultrasound in non-destructive testing, NDT. When it comes to testing materials and structures, destructive methods can be costly and impractical. That's where non-destructive testing, NDT, comes in. Ultrasound is a leading technique in NDT, allowing us to inspect materials without altering or damaging them. Industries like aerospace, automotive, and manufacturing use ultrasonic NDT for flaw detection, material characterization, and even bond testing in composite structures. By analyzing wave reflections and signal patterns, technicians can identify hidden defects such as voids, delaminations, or micro cracks. One commonly used ultrasonic NDT method is phased array ultrasonic testing, PAUT. Unlike conventional methods, PAUT uses multiple elements to steer and focus sound beams, providing detailed and accurate scans of complex structures. This technique is revolutionizing the way industries inspect critical components. Advancements and future of ultrasonic technology. With technological advancements, ultrasound is evolving beyond traditional applications. Artificial intelligence and machine learning are now being integrated with ultrasonic inspection systems, improving defect detection accuracy and reducing human error. Automation is another game changer. Robotic ultrasonic testing is making inspections faster, more precise, and capable of reaching complex geometries. This is particularly beneficial in industries where safety and reliability are paramount. In the future, we can expect more innovations in ultrasonic imaging, wireless sensor networks, and even real-time monitoring of infrastructure health. These advancements will further enhance the efficiency and reliability of industrial processes. As we've seen today, ultrasound is an indispensable tool in modern industries, from ensuring precision in metrology to upholding quality standards and enabling non-destructive testing. With continuous advancements, ultrasound will remain a key player in industrial innovation. That's it for today's episode. If you found this information valuable, don't forget to like, share, and subscribe to Consumer Times for more insightful content. Have any questions or thoughts? Drop them in the comments below, and we'll be happy to discuss them. Thanks for watching, and see you next time.